So every time I try to understand and grapple with this um, quantum physics, quantum computing, intuitions fail, right? And what I'm realizing is that we kind of take intuition to be for granted because everything else that we study can be can have an analog in sort of real world,
Real world, yeah.
the observable classical world that we can kind of map to and visualize and think. But
Mhm.
the realization I'm coming to is that maybe some of this stuff that you have to deal with in quantum mechanics and quantum computing, the math behind it has no analogy in the common sense, the classically observable world that our common sense is built on. So
Mhm.
the the idea that somehow we can understand this without really going deep into matrices and um, the math of it just is probably just not possible. At least that's how I'm thinking about it. Uh,
The closest classical intuition is the one that I think often people use, which is, and Feynman famously introduced about the double slit experiment. It,
mhm,
I think, is the closest one can get to not necessarily how a quantum computer works or how Schwab does, but for the most part, it can come very close to it with thinking of, you know, if you're shooting electrons to slits, then how come that if I shoot only one electron, it goes and hits someplace, but if I shoot a million, then suddenly the histogram looks like it's waves, right? Whereas a single particle is just one particle. It's not like a wave, right? So whereas if I shoot a light beam through double slit, every time I see there's a wave, but if I
mm,
were to tune down to one photon, again I'll get a particle just as if it hits one point. And the fact that things, be it matter or light, can amplify or destroy, constructively or destructively interfere, is really the basis of all this. So I think the only intuitive thing I have found which connects these is this double slit experiment and deeper thought of that and all its sort of manifestations one way or the other. Even the Shor algorithm can be thought
mm,
of that you're feeding, n beams to n slit problem and then using that for the factorization using. But then you're right that we are we generate as human beings we don't encounter phenomena, don't feel phenomena that is a hybrid of the two, or matter, particle and light and wave. We either feel one or the other because on a classical scale, on a large scale, the other part is deeply suppressed. The other nature of it is deeply suppressed, mainly because of this correspondence principle. If you go to very large numbers, you have this delta n, delta phi number, or the phase of number of particles, and the phase of that wave must be greater than or equal to something. So generally, the only things we can feel or touch or sense or smell or see are where one of them is completely suppressed and the other one is very high, because our sensory, inputs and all are not sharp enough, not sensitive enough to detect at the single level of the
mm,
other. By the way, that being said, this is very interesting. Bob Bialek from Princeton gave a talk recently showing that the human eye can see up to a single photon if you do things right. So that's
mm.
quite interesting. I was quite amazed at that. And anyway, yeah. So that being said, uh, I would say that certain things, such as a superconductor, it's really a macroscopic object where the quantum part of it is manifested in a kilometer long wire. The whole thing is one
Mm.
quantum object. There are very rare things like that where the quantumness is preserved with billions and 10 to the power 20 particles, and the whole thing is still coherent, which is why it's
Mm,
being used for the transmon qubit.
mm,
But I agree that this aspect of uh, very famously, this is called the Copenhagen interpretation of quantum mechanics, that nature is an engine that is going to do all the work, but just don't try to ask about every little detail of how it's doing it. You can only get, if there are a million windows, you can only get to peek from one window, not all of them at the same time, because if you try to peek through that, it becomes classical. So it's somehow doing a lot of work, but if we are clever, we can take advantage of that quantum dynamics. If we, on the other hand, we have always used the classical. I think this is an interesting point of view, that it's more anthropomorphic, meaning human beings have developed from both quantum and classical in many ways. Our birth and our origins are all tied up with that. But our senses have not necessarily, for good reason, I think. Our whole consciousness and existence depends on maybe certainty rather than uncertainty. And maybe we have developed so that we have, somehow nature has realized that if you had that intuition, you won't be an animate object, you won't have consciousness or something like that. So anyway, I think that consciousness may be related to how quantum you are. So maybe, yeah. So the most, what we think, which is no consciousness or self-awareness, are atoms, which apparently don't know anything. But who are we to say? So whereas if you have a collection of a very large number of atoms, like you and me, somehow we have developed consciousness and become classical.
I think this question also has a quantum nature.
It is true. It is true. Yeah. The Copenhagen argument is, interpretation is, I think famously, I think maybe you have heard it many times, but it is doing it. So just shut up and make use of it. Shut up and calculate is the famous statement for quantum, that don't try to be too philosophical about it, because it's there whether you believe it or not. Use it. Is what, that's the famous statement that people use sometimes. But I think we should be philosophical. Why not? It's so rich, and we should think about its both the beauty and its mysteriousness. That's always good.